Welcome to the Padhai Karlo JEE preparation channel. You can practice more problems on this exact topic on our Padhai Karlo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is electric flux, the foundational concept behind Gauss's law. Let's begin. Electric flux through a surface genuinely measures the total number of electric field lines passing through that surface. For a flat surface of area A placed in a uniform field, the electric flux through a surface genuinely measures the total number of electric field lines passing through that surface. For a flat surface of area A placed in a uniform field, the flux is genuinely given by phi equals E dot equals Ea cos theta, where theta is the angle between the field direction and the surface's normal vector, the line drawn exactly perpendicular to the surface. Flux is genuinely maximum when the field is exactly perpendicular to the surface, theta equals 0, and genuinely 0 when the field runs exactly parallel to the surface, theta equals 90 degrees, since in that case, no field lines genuinely pierce through the surface at all, they just graze along it instead. For a surface that isn't flat, or a field that is genuinely defined through the integral of E dot da over the entire surface. For a genuinely closed surface, one that fully pure close thermal p sahising Paschimi Afriki Rendinavian Leoni volume, like a sphere or a cube, the total flux through the entire surface is genuinely given directly by Gauss's law, the close of E dot dA equals Q enclosed over epsilon naught, where Q enclosed is genuinely only the charge sitting inside that closed surface. This is genuinely the single most important fact about flux through a closed surface. Charges sitting outside the surface genuinely contribute 0 to the total flux, even though they do still influence the field's exact value at individual points on the surface. Their field lines that enter the surface on one side genuinely always exit again somewhere else, contributing 0 net flux overall. This specific property is exactly what makes Gauss's law such a powerful shortcut for finding fields in highly symmetric situations. The single most frequently tested JEE skill here is genuinely computing flux through just one face of a closed shape like a single face of a cube with a charge at its center by symmetry. The total flux Q over epsilon naught genuinely splits equally among all 6 identical faces, giving Q over 6 epsilon naught through any single face. A frequently tested trap involves genuinely a charge placed outside a closed surface entirely, remembering that this contributes exactly 0 to the total flux through that surface, regardless of how close the external charge sits to the surface. A very common error is assuming a nearby external charge must contribute something. Also remember that flux is genuinely a scalar quantity, not a vector, and its SI unit is genuinely voltmeters, or equivalently Newton meter squared per coulomb, distinct from the units of the electric field itself. Let's recap. Electric flux through a flat surface in a uniform field is Ea cos theta, maximum when the field is perpendicular to the surface, and 0 when parallel to it. Through any closed surface, Gauss's law says total flux equals Q enclosed over epsilon naught, with charges outside the surface contributing exactly 0. Symmetric splitting like Q over 6 epsilon naught through one face of a cube with a central charge, and remembering that flux is a scalar are the key skills this topic tests. That's electric flux. Keep the Gauss's law relationship and the external charge contributes 0 rule sharp. They're the foundation for every field calculation that follows in this chapter. If this video helped, please like it and subscribe to Padhai Karlo for more JEE preparation content just like this. See you in the next one.